Guys, my name is Femi Ayeshiro. We are looking at structs in this series, and then we are going to walk through some materials, and then we are going to get back to the coding. So what is struct? Unlike every other types that we have in Go, structs are unique, structs are user defined. So every other types that we have in Go, it's already defined for us, like integer, like string. So struct type helps us to be able to define our own types, and this is extremely useful when you are building your REST API. You are going to need struct, and it's important that we understand how struct is. Alright, so struct is composite data type. So struct supports user defined custom type. Alright, so struct tries to represent real world entity with its property. So struct is, if you are coming from a different programming language, maybe object oriented programming, we talk about class. So in a class is where we define the property. So it is similar to that, even though Golang is not OOP language, but struct models something like that, right? So with struct we could achieve something like a class. So in a struct we define our own type. Now, so struct is user defined, that you can define your own type, your own types. Okay, so I want us to struct our composite types. So when you want to define a type that consists of several properties, so we can define a type that contains several properties. So you see that this is struct. Struct itself is a type. Then it's like a box. Then inside that box, we are now able to define as many types as we want. But this time around, we are defining a types with a feed, so with a name. We are going to get into that. So we have several properties with their types, grouping piece of data together. Then one can access that data if it were part of a single entity. So we looked at basic data types, composite data types. We've talked about collections, that it's a combination of data types. So the same thing too with a composite type of struct. It's a combination of other types, and that's the unique thing about struct. So structs are value types. It means that when you pass a struct inside a function, it's only a copy that is being created. All right. So our data, their value types, are constructed with a new keyword. The component piece of data that constitute the struct types are the feeds. So in a struct, we define our feed. So a feed is going to have a name, and is going to have a type. Feed name within a struct must be unique. However, Go does not support the concept of class. The struct type has a much more important place in Go. So this is the format of the definition of a struct. Right. So what we are seeing here is that we have a type, we have an identifier, which is a name given to our struct, and then we have a feed. So we have the name of the feed, which is feed 1, and then this is a type, feed 2, this is a type. So I want to walk us through some examples. Let's check our code. And so when you are to define your struct, you start with the word type. So you can define it outside the main. So we are going to do struct type. I'm going to put tags here, and then we are going to put the word structs. Okay, and then you have your braces. So what we are going to do here is to do title, and then our title, these are feed. So this is whatever you have inside the struct. So the name of the feed is title, and then the type of that feed. So every feed that is inside your struct, you also have to the feed has to have two things: name and then the data type. And the next thing we are going to do is we are going to have done. We are going to have say bool, and that is it. All right, so we are done with our struct. Now, so this is a blueprint. This is a template. So what we need to do now is to instantiate the same way we do in OOP. We instantiate our struct. So you want to build, there has to be a building plan. There has to be architectural design of how the building is going to be like. So that is a model. That is a blueprint. So you now go to the sites and start building according to the. So this is like we are having a template after what we want to build. So we have to now instantiate. So you have to get the land, concrete, put materials, and all of that. So the same thing is what we want to do here. And what we're going to do now is we're going to instantiate. So we are going to create a variable, I call it T, and then we start with our struct name. Then we start with our braces. So this is how we instantiate a struct. So we are going to be including the feed name. So we're going to do title like this. So let's say Go programming tutorial like this. Tutorial like this. So Go programming tutorial. So like this, put a comma, then the next one is the name of the field. Then what value are we setting? So we are going to set it to false. Okay, and that is all. Alright, so we are good, put a comma. So now what we want to do now is we want to print this we want to format this. Print int like this. I'm going to do T. And that's all we need to do. So what we are doing here is to instantiate the struct with our values. Right, so we have already created the template here, so we need to instantiate here. So we are going to do, let's clear it also, and let's do something like this. What do we see? We are seeing Go programming tutorial and then false. So that is structs in a nutshell. You can create as many things as you want here. They are not, it's a user defined struct, it's a user defined type, custom defined type, meaning that it is left for you to include as many things as you want in that struct. Okay, so that is that. And we've talked about collections, and we can also make this, let's say we want to have let's say we want to have many things. Let's say, let me put another one, let's do X. Let's say we want to have X like this. So I want to have another one like this. Let's say title, let's say Java programming tutorial like this, and then we are going to have done, so it means true like this. Okay, so what it means is I will have to do dot, and then I want to do this, format it together. So what do we have here? So can you see what we are seeing? We are having Go programming tutorial false, Java programming tutorial true. So instead of having to define them like this, a more simpler way, you can put them together in a slice. We've talked about slice in our previous video, one of our videos. So we're going to do something like this. Instead of doing it like this, I'll just take it like this. We can just do T like this, and then since it's going to be slice, you're going to, when we are defining slice, we have to put a square bracket. That's what defines a slice, and then the data type. So if it's int, so let's say this is slice now. So this is how to define a slice: 3, 4, 5. Let's say 8. So this is a slice. So if I print this out now, all right. So let's see what we have. Let's print it out. What do you see? You see 2, 3, 5, 8. So that is a slice. All right. So since we have multiple things that we want to print, instead of having to create variables one after the other, then one thing we can do is we create a slice like this, and then we put the name tax, because our type is what is a struct tax. So what we now do is to do something like this. All right, so I'm going to do something like this, and then once you open, so this is a struct, this is a slice. So that means a slice of a struct. Okay, so we are having struct inside a slice. So what we are now going to do is individual. We're going to have title. We're going to have the title is going to be Go programming tutorial like this. We're going to have done, which is going to be false like this, and we are true. Then the next one is going to be title, which is going to be Java programming tutorial. Then we are going to have done to be what? True. Okay, so we can add one more. We can add title to be what? Python programming tutorial. I'm going to have done to be what? false. And that's all, right? So I want us to take note of something here. What we have here is we're having a slice of what? Structs, which is slice of tags. Okay, that's just what we have in here. So I'm just going to print to the console. What do we see now? We expect to see them inside. Can you see now? Can you see that we're having that square bracket? So we can see that all of them, right, they're inside the square brackets, and that makes sense, right? So I've showed us how to instantiate our struct, and then how to put our struct inside slices, and this is just the basic, basic. I'm still going to do like 2 or 3 examples so that we understand perfectly. So this is structs. All right, so one major thing we are going to move on to is to talk about methods. So I gave a difference in the first series. I gave a difference between methods and function. I think that should be in the second series, where I talked about functions extensively. So what's the difference between functions and methods? So a function is a basic block of code, right? So instead of repeating yourself, you can just write a line of code, write some code, maybe a code that adds 2 numbers together, right? And you can begin to call the functions and begin to pass in arguments or parameters, and you get different results. Right, so methods are functions, but methods are more specific to a data type. So we are now having a function that is tied to our struct. That is just what it is. So when I'm doing the coding, we are going to understand much better. So what we are going to do is, a go method is a function that acts on a variable of a certain type, so called the receiver. So the struct that we have created now is a receiver. So we are going to have a method that is going to have that receiver. It's going to take in that receiver. So therefore, a method is a special kind of function. A method acting on a variable in Go is similar to the object of a class, calling its function in another object-oriented programming language. So in object-oriented programming language, after we've defined our class, then there are methods that will be defined inside that class, inside the confine of that class. So that means those methods are meant for that class. So when you instantiate that class, then you can also call those methods on the instance of that class, and that is how it works. So the receiver types can be almost anything, right? So the receiver doesn't have to be a struct, but in this case we are using structs. Anything, not only struct type. Any type can have a method, even a function type or aliases for int and all of that. So the receiver can be an interface type. Alright, so lastly, a method cannot be a pointer. So this is just to give just to explain more and more and more. So I want us to just dive into some examples and then see how this method is. Alright, so we're going to see some examples and then understand this better. So let me just take this out. Right, so let's take this out. Let's take it out. Let's give us another example. So we are going to have an example, a simple one. So we are going to have type person like this. We have struct like this. So a person struct. So we're going to have a name. So the feed is name. The feed now must have a name and a title and a data and a type. So which is going to be what? String. Then we have age, which is going to be what? Int. So I want to create a method now. So the method is going to be func. Then this. You see that normal function, what comes after the func is going to be the identifier, the name of the function. That is how it works. So when you create a function, what comes after is going to be what? The name of the function, which we call the identifier. But in our case, it's going to be the receiver. It's going to be this that we're going to be pointing to. So we are going to put P. So P is what? Representing this struct. Can you see now? You can see. So that means P. So P is P. Let's see. I'm just going to write something here. P is represents person. So when we say P, we are saying person. That's what it means. All right. So we have P, and then the name of the struct. Let's say greet, like this. The name of the function. Sorry, the name of the function. Right. So and that is that. So we get it now. So when you see any parentheses after the function, that shows that that is actually what that is a method, right? So because it's taking in data of what the receiver is taking a receiver here. All right, so that is that, even though it's a function, but this is a method. So the next thing we're going to do now is to do fmt print int like this, fmt print int, and what we are going to do is we're going to do hello my name is so. Okay, so this is going to be, let's format it properly. Printf my name is, I'm going to use x for string, and I am okay, integer is going to be d, yes, old. So we're going to do this, and like this. So we're going to do p dot, can you see now? So since p is in quote represent the person, so I can do p dot, we I want to access the feed, p dot name comma p dot h, and that is it. That is it. So what we need to do now first is to what? Instantiate it. This is what we have done here, is to create a blueprint, right? So we have to instantiate. So instantiating is, let's do p, creating a variable, and then what do we do now? We instantiate by calling the person, right? And then we do this. So we can now do name. Name will be what? Let's say name is Steven Stone, right? And then we now say the age. The age is what? Let's say the age is 50. And that's all. Just make sure that the comma is there. So what do we need to do is, if you do fmt.printint like this, what you get is p. So let's do p. So what do we have? Let's clear this. So what do we have now? So what you are seeing Steven Stone and what? And the age. So what you have here is Steven Stone and what? And the age. So but what we want to do is, we want to, how can we now call this method? So the method cannot be called until you instantiate the struct. So I can now call the method on the struct. So what we can do here is to do p dot, you can see p dot greet method, and that's all. So by saying p dot greet, it's going to instantiate, it's going to call this method for me. So when we clear our console, what do we see? So we see, hello, my name is Steven Stone and I am 50 years old. Do you get now? But I can't just call greet, unlike the way you call method like this. It's not going to work. You have to instantiate your struct, and then you can now, after it is when you have instantiated, right, the variable, then you can now do p dot greet, and that is how it works. Okay, so that is one example, and we are going to see other examples, right? So let's check some other examples. We've done this example before, but I think it's still a bit similar example that's just added some few more things to it and just do it in a different way. So let's do type tags string. Oh, it should be struct. So we are going to have title. Oh, title is going to be string. We have done, It's going to be bool, right? So let's have a method. So what this method is going to do now is to do add tags. It's even a function I'm creating here. So you're creating a function, add tags. So this function is going to take tags. So you are going to create. So what am I doing here? So what I'm doing here is that this is a function, not a method, because if it's a method, it's going to have, there's going to be parentheses, there's going to be parentheses, right, and then that is going to take this. But what I'm doing here is a method, is a function that takes this function, requires what? Requires a slice of this struct. That's what I'm trying to do here, right? So it's better we don't. Then we have title, it's going to be string, and then we are going to return. So what we are returning here is what? Task. Okay, so we are returning a slice. That's what we are returning here, a slice of the struct. So I'm going to do t, like this. So we have a task like this. So what we are doing here is to instantiate it here, and then call it title like this. And then we have t, we are going to return like this, return append tags /t. Now this is a method, right? So what I'm passing in, the argument I'm passing in here is saying that I'm passing tags, but also this task is to represent that I'm passing a slice of this struct, and then title of string, and then we are returning what? A slice of tags, which is this. So I'm creating a variable where I'm instantiating. So what is happening here is to instantiate the struct, and then what I did here was to set the title, of course, the feed. When you instantiate the feed, then I'm now setting the title to what I'm going to pass in inside this place. That's what we are doing. So what we are now doing at the end is that we are saying append the tags. So the tags here, right, and then we also appending it to, we are appending t to it. So this one we create. This we create a tags for us. Then what we are doing appending is to add the tags created to the what? To the what? We are adding it to the what? To this slice, right? Which is this tags. Do we get now? So we are creating a tags here. Then what we are now doing now is to append it. We are now adding it to what? To our slice. So that's what we are doing there. Right? So what we now want to do now is to so let's instantiate. Okay, so let's instantiate. I'm going to instantiate, so I'm going to do, let's do new tags like this. New tags. So I'm going to create. So as you can see that I'm creating a slice. Okay, I'm creating a slice of this struct. So let's create this. So let's just do this, what we have done before, but I just wanted to put a method there, and title, let's just do go done. Let's do false. Title, let's do Java. Done, let's do true. And that is all that we want to do. Alright, so if you print it, of course, you get a slice. So we'll do fmt print. So it's going to be new tags if you print it out. So you should get a slice. What do we get? We get a slice. Very good. So that is that. So how do we now call this? So this is a method. Okay, so this is a method. This is a function. Sorry, it's not a method. It's a standalone function. You get now? So that means we can call. What it means is that we can call this method on its own. Okay, so let me just take this. What I'm saying here is that we can do add task. Okay, so don't forget that this is not a method. This is a function on its own. All right, so we can call the function directly, and then what we are going to do now is to I think I should, yeah, we can call it alone. Okay, so I'm just going to do something like this. Let's just do. So I'm going to call it. I'm going to call this function. So I'm going to do. Let me do var to do's, right, and set it to a slice of tags like this. A tags. All right. So what I'm saying is I've created a var, right? So this var. So if you check this var now, let's do fmt print, because struct is a value type, right? So let's check what we have to do. What do you see? We are seeing empty. It's going to be empty. Do you get now? So it's empty. So what we want to do now is we want to begin to add to it. That's what we want to add. So what we are going to now do is to do the variable to do's equals to what? Add tags. Okay, we can see add tags, and to add to our tags, we are going to do to do's. All right, to do's, comma, learn programming like this. So don't forget that the to do we are talking about here is the first. What is the first? This one is what? It's taking in what? A slice. So, and this is a slice. Can you see? The name is to do's. That's what I'm putting it. Then title. This is a title. All right, and that is all. So if I print, let's print this out now and see what we have. What do we see now? What we are seeing learn programming first. That's what we are seeing. Very basic, right? So if I want to add another one now, all we have to do is to do to do's equals to add tags. So we are going to pass in to do's again and say Java programming. So let's clear and check again. What do we have? So what do we see now? We see learn programming, Java programming first. So that is that. So what I'm using here is just functions, right? So that is another example. And then so we are going to look at a very important, because a very important what is it called, method now. Okay, because when we come to our this, let's just get to this. I'm going to do, all right, so if you come here, you see that struct is a value type, meaning that if you pass it to the original if you pass it, a method does not changes the original value of that struct. Okay, so I want to, does not modify the original data. That is what I'm talking about here, right? So the original data is not being touched. That is very important. So if you create a method, so let's check this now, and so we are going to do something. Let's get another example. So just to explain the value type, and then we are going to use a pointer. So as a value type, so type user. Let's do type user like this. We have a struct like this. So we have a name, still the same thing, string. We have age, and then we have int like this. So we are going to create some methods. So we have func. I'm creating a function now, right? Is this a method? Yeah, a function updates age. So let's do this. Okay, so let me just make it. Let me create a method. So we are going to do u is going to be user like this. So this is a method, right? So we are going to do is going to have a new age, passing a new age here. So the new age is going to be int, and then we do something like this. So we say u dot age. Can you see? Equals to new age. So that is it. Okay, so that is what we have done here, right? So what we need to do now is to instantiate. So let's say u equals to this. So we are going to do user, we know it's name, let's say name is Alice. Then we are going to do age, it's going to be 38, and that is it. So if you do fmt dot print now, just want to have instantiate now. I've done instantiate now. Oh, you. So let's clear this. Alright, so what are we doing wrong? Okay, we have u declare but not use, and we are using u here. Why does it say declare but not use? On use feed name u dot. Okay, so let me just console to the log and see what we have. Alright, so we are declared, we are not using it. We are using this. We are using this. Let's check what is happening. Okay, so I'm going to, let me just write a function here. Let's do this like this. Let's do u user like this. Okay, right, dot age. Okay, let me make this one a pointer like this. Okay, so I'm making this one a pointer. So what else? Okay, let me clear. So what are we doing? Okay, so I've instantiated this, right? So that's what I've done. So I want to call this method. I want to call this function. So how do I call this function? So let's do updates. So this function, since let's call this function, and I'm going to do, let me put it here. So let's do updates age. Okay, you're updating age. Update age. So we are going to do all right. So now this is where this is very important. Since we are passing this as a pointer now, this struct, right? I'm passing it as a pointer, right? The reason why I'm passing it as a pointer is that so that whatever value I pass here can edit this directly. This struct is a value type. That's the essence of what I'm trying to do. Okay, so it's a pointer now, means that it's going to have a reference. It's reference to this, so that whatever I set here, we have. So since it's a pointer, right? So you know a pointer now. A pointer. Remember in the first series we talked about a pointer. How do to pass a pointer now? Is we are going to use this sign, right? So I'm going to now do something like this. I'm going to do this, right? U, and then what else are we passing? We are passing the age. So the age is 30. Let's say it's 30 now, right? So that is that is that because this guy is expecting a pointer. So we can't just pass ordinary U like this. No, it needs a pointer. Why? Because it needs to modify this directly. That's what we want to do. So we've called it, and then what are we now going to do now is, so we've just done the settings. That is what we have done here, right? We have done the settings here. So I want to call the U. Let's see what we have. Let's call U. So we can see that what Alice has been changed to 30. All right. So Alice has been changed. Just calling this value again. Why? Because this function here has changed it. Has changed the value that was set here, which is 38. Right. So it has changed it to 30. So whenever we have to change something directly, then we have to use pointers. So that's how it works. I want to do something here. So let me return. Okay, so let's return a user. Okay, we are not returning a user. All right. Okay, so that is how it works, right? Because once we have to change the value directly, we have to use a pointer, right? So that is one example. I want to a pointer with a receiver. Okay, this is also, let's check out this example before we move to interfaces. So we can also do type counter structs like this. So we have value to be int. Then we can write func s like this. We have counter, right, making reference to it as a pointer here. Then we have increment parentheses, and then we have this. So this is in c dot value, right? So plus plus. All right, so let me remove this. So let's leave this like this. Okay, so what else we are going to do now is let's instantiate it. We're going to instantiate and just call counter now. And what are we going to have? We're going to have value to be what? Value to be 10. Right, so what are we going to do is so I'm going to call this method, right? The way we call method is, so I've created an instance now, right? So I want us to always know that I've created an instance which is C, right? So okay, so the instance, you can see I've created an instance which is 10, right? So what do we want to do now is what we are going to do now is to do, I'll leave this one like this. Okay, let's come here. So let's do c dot increment. So what are we increment? So it's just calling this method, right? So let's see. What do we see? We are seeing 10. Why are we seeing 10? Even though what we are saying is that this should increase it, right? So we are seeing 10, nothing changes because it is a value type. It is a value type. So if we make this one a counter, let's make this a counter now. Let's make it a pointer. So that means you are saying this struct is a pointer now. So once it's a pointer, right? So let's try and call this method. So we are calling the method now. So let's see what is going to happen. We can see that it has changed to 11, right? So if you call this again, let's try and call this again, right? So we are calling it twice. What do we see? We are seeing is struct. So it is modifying the feed. Why? Because it's a pointer. So if it's not a pointer, nothing is going to change. So with the examples I've given in the past, when you're passing pass by value, pass by reference. So a struct passes by what? By value. So it means that whenever we have to whenever we are passing a struct down to a method or a function, it is by what? It is by value. A copy is it just copy that struct. That's what happens. So a copy is being created here, right? So if it just copy. So whatever we do inside any method or function, it does not affect the original data. So but if you want whatever is passed down here to affect the original data, then it has to be passed as what? As a pointer. And that is how it works, right? So finally, I'll just talk about factory method, right? So there's something called factory method or factory functions, right? So it's a function to instantiate the struct. So this is how it is. You see it. I'm going to show us some code examples now of factory function. So let's say we have type of a car like this. We have a struct like this. Let's say we have the brand to be, this is a string. We have speed to be int, right? So what do we have now? So we have a func new. So most factory function, right, start with new. So this is a function, not a method, because it's not receiving anything. String, you can see speed, which is int like this. So a factory function will return what? Is going to return an instance of that struct. So you see car like this. You can see it's returning what? This struct. Okay, but it's returning, it's taking it as a pointer now. This. So what are we going to do now? We're going to return. So if it's going to return it, we're going to have this. So what we have is brand. It's going to be a car here. So what we have is, so you are saying car, we are returning this. But what we are returning is what? We want to be able to modify the original data, right? So that is why we are doing this. So brand will now be equals to what? Brand like this, right? So speed is equal to what? Speed like this. How we get it? So we are passing this. So whenever we call this is what we call factory function. So whenever we call this function just initialize, instantiate the struct for us. That's what this function does. Instead of us having to instantiate the struct like this, that we have to do t equals to, maybe car like this, brand and all of that. No, this calling the function just instantiates the struct for us, create an instance of that struct for us, and then so that is that. So I'm going to create other function. Just create one more function like this. I'm just going to show us examples very soon. Car show like this. So this is a method now, right? You can see that the method is receiving this, is taking this is receiver, this is struct. The receiver is passing inside this method, then the name of the words of the method show. So this is just to show. So we are going to have fmt.print like this, print f. So we're going to have brand x like this. We're going to have speed like this, d. We're going to have kilometer hour like this. Alright, so we have c dot brand, c dot speed. Alright, so that is that. So what we are going to do now, so this is a method, right? This function, this function is, we call it factory function. So when I get to showing us the API, I'm going to come here and show us the API part soon. We are going to see the factory function. So it's a convention. Whenever you see new, it means it's a factory function, and that function is to what? Create an instance of that struct. Alright, so it's something that we need to take note of. So what we are going to do now is can do car, right? So I'm setting it. So what am I doing now is to call this guy here. right? So let's call this guy here. You know it's a method, right? You're going to do this. So put the name of the car that you want, Toyota, right? So what else do we have to put? Maybe speed 120, like this. All right, so that is that. So this will create an instance. Let me see if I can print it out like this. Dot print int like this. So we have car. So create an instance of it for us. So can we see? We can see that an instance has been created for us. Okay, so that's that. So we have an instance that has been created for us. So you can see Toyota. So you can create as many as you want. So maybe T. This could be a new car. This can be Honda, and then this can be 190. Right. So let's just do T like this. Let me clear it out and then see what we have. So you can see Toyota, Honda, right? So this is not where we are even going. We want to print it out. So we can see that a method here, this method has been created to print it out. But you can't use a method without first of all instantiating. So now that we have instantiated it with a real value, then we can now call this. So what we can now do now is to do dot show, right? So that is what am I doing? Let me take it here. We don't need to print f again because in the show we are already printing it. So we are going to just do car dot show. Okay, I should have made this a capital letter. All right, so let me take this now. This is going to be show. So show. Now you can see we are passing show. All right, so that is all. So we're going to do, what do we have now? So you can see that brand Toyota, speed 120 km/h. Can you see now? So I'm just calling this method after I've instantiated it here, right? So this is it, car.show. So if I come here again and do something like this, t dot show, right? So let's see the second one. What do you see? So you're going to see brand Honda, speed 190 km/h. Okay, so that is very, very straightforward. So this is a factory method that creates instance for it, and that is how it works. So finally, I'll just do one more example, and then we are going to move into interface. Just do a real small stuff on interface. So let's, because it's possible for us to embed structs in another. So we're going to have struct, animal struct like this, and then we have a name which is string like this. Okay, so I'm going to create a method of that struct, which is going to be a, that would be animal like this. So we have the animal can speak like this, and then we have this. So we are going to have fmt.print like this, print int. So we are going to have a, you know that a, right, represents the animal struct, right? A, we have a dot what, dot name, right? So makes a sound. So when we call this method, this is what we printed. So it's going to give us the name of the animal that we need instantiate. Okay, so another one. So so we have animal. So this is a struct of animal. So if you come here now, let's just do something I want to show. So this is a struct of animal. So let's just say T like this, and then we say animal, right? So the animal can be, let's say, goats. The name can be what? Goats is a string, right? So let's say goats, right? Put a comma. So what do you do? FMT. So I just want to instantiate it. So let's just instantiate, and you see So what do you see? You see goats. Now, what do we do next? So let's take this. Let's just do. See, before you can call a method of that struct, you have to instantiate. So you're going to have t dot what dot speak. Can you see now? So what we have here is going to be, okay. So you see, goat makes a sound, right? So that is that. So clear. So but of course, what we want to do now is to have another struct. We're going to have type dog struct. So this type of struct is going to embed. We are embedding the animal struct. So you can see that this is struct. Then inside the dog struct, we are having what? Animal struct inside. And then we are not going to have breed. Breed is going to be what? String, like this. Alright, so let's have a method. Okay, do we have to have a method? Okay, no. So let's just leave this. So what are we going to do now is, so what we are going to do now is to do d. So we want to instantiate this dog. But don't forget that the dog has what? A struct. This is a struct. Alright, so embedded struct here. So we have dog, right, creating an instance. So we are going to have animal. So we know that animal struct has what? Has a name now. So we're going to have a name, which is going to be what? Body like this. Then what else? We're going to have a breed. So the breed is going to be what? Golden retriever. Put a comma. Okay, so this is a struct. Then golden retriever. So that is that. Trying to check out what's happening. We have, okay, oh, this is animal. So what we have here is we have animal. Oh yes, there's a mistake here. Now this is an embedded struct, right? So this struct is this. This is struct. So what we are going to have is to say the name is animal, right? So we are going to have animal struct like this, right? So animal struct. So inside this we are going to have this, like this. Then what we are going to now have is going to be what? Breed, which is going to be what? Golden retriever, like this. All right, so that is, so we have so what we have is, so this is struct, right? Because this struct animal is embedded here. You can see that this is struct that is embedded here. So we have to define it, so because it has to be we have to initialize this too. But initializing it is going to be inside what? The initialization of the dog. Do we get that? It's not as if we are initializing it outside. I will see if we can initialize it outside. So dot print of, this is D. I just love breaking things down, and right. So what do we see? We can see body, and then we have golden retriever. So another way, instead of avoiding this, is to just do, we can just say A here equals to animal, maybe animal here, and this settles it. So we know that this is going to be a name. Let's say body, like this, and that works. So instead of having to write this like this, I think we can just put A like this and put a comma, right? I'm still wondering why this is not working. mixture of value, struct in the listra. Okay. Animani. Okay, so let's leave it like this. Alright, so that's that. So what we want to now do is, can we now say d dot speak, right? So we are saying d dot speak. Okay, so let's see what we have. Just trying to see. So you are seeing body makes a sound, right? So what happened is, because this struct, this is defining composition now. What we have done is defining composition. Okay, so we can see that the method of this struct, okay, because the struct is inside this place, this struct, we're able to now call the method of this struct. Alright, so because the struct is used here, that means this dog have access to the wealth method, and that is what we have done here, right, by having these results. Alright, so that is that, and we are going to talk about interfaces now. So I'll just talk about interfaces, and then we now move into seeing some code examples here, right? Where I use structs, of course you can see I'm using struct here, so I'm going to walk us through this code. So much things to learn there. Alright, so I'm just going to, let's take this out, and then we talk about structs and interface. Right, so the first question is, what are interface? So interface are abstract types, right? And then they're also amongst the advanced types that I said. So interface just defines behavior, right? So in interface you have a method, just a method, right, that defines the behavior. So what means is that a struct can implement the method of an interface, or can implement the interface. Okay, so let me just give us an example here. Just do an example. So what we are going to do now is we are going to have a type shape, and then we call it interface, right? So we are going to have area, then that's all. Then it's going to return float 64. That is all. So interface is going to give you, is as this function signature, just define behavior. So this interface is just to define area, that is all. Alright, so we are going to define some structs. We are going to define a struct, not some. Define a struct, rectangle, structs, like this. Okay, so what we are going to do is going to do the width. We are going to do the width, and then we can put it together like this, width and height. Can do float 64. Right, so it's the same thing as doing something like this, but since they are both float 64, so you can have them on the same line. So but let's leave it like this. Right, so we are going to have a function func like this, a method how that takes in rectangle, then we have area like this. Okay, so we are going to have float 64. Right, so now what we have here is that the struct implements the method, is implementing the method of the interface. So that's what we have here presently. So I'm going to return har dot width like this times har dot height like this, and that's, so let's come to our height. Let's come here, har is going to be this, so we're going to have rectangle. So I'm creating an instance now, that's what I'm doing. Okay, an instance of, okay, what I'm doing now is instantiating my structs with values. So it's going to be 5. Let's say the height is going to be 10. Okay, so if you print it out, you get something dot print. Let's see, this is R. So what do you have? You should have a value. So you have 5 and 10. Alright, so how do we now call this method that is being defined by this interface on this struct? So we are saying the struct implements this interface, right? Because of this method, you are calling the method on that struct. So what we are going to do now is to do fnc dot. Okay, there's no need for this. So let's say area just going to show some code examples. r.area, that's all that we need to do. So let's clear and let's see. So what do we see? We are seeing 50 because it's what? 5 times 10. So that is that. Okay, see, so that is that. So I'm just going to show some examples in some code base, right? So a method just defines the method. A method just defines an interface defined method. Do you get that? So those methods that are being defined by an interface can be implemented by a struct, or let's say you have series of structs or series of types or data types. So once they implement that method, so it means once they use that method or they implement that method, what it means is that once that method is needed. Now in our case, now we see that area method is used by this struct. So we can now see that these structs implement this interface. All right, so let's see some example, and let me just show some code example. Right, so what we have here is we can see we have a struct. Okay, we are defining a struct here. That is what I am doing here. So this is a struct. Okay, application, then we have what? The feed. All right, so this is also a struct. Can you see now? So it's embedded here. Okay, so this is an interface, and I'm going to take us there. All right, so you can see that these are structs that I've defined here. Right, so these are structs that I have defined here. Right, so how do I instantiate it? So just take note of application and config. So you can see that these are methods of that struct. If you check this code function now, you can see that these are methods. These are methods. Why? How do you know that is a method? It's because it's receiving these structs. Can you see? It's receiving these structs. That's how you know. It's receiving these structs. This guy received these structs. Alright, so that's how you know that is a method. So that means the app dots. So you see that the app dots, okay, is needed. So what I'm going to go into is, let me show you where I'm instantiating. So how do I instantiate? You see that, you see config here. Can you see config here? So this is where I'm instantiating that struct. Okay, you can see I'm instantiating. So go back to, where's our API? You can see that, you can see the things I have. You can see. Let's try and open it side by side. I'm not sure I'll be able to do that. So let's put open here, and then let's close this guy. So if you check now, what are you seeing? So I'm instantiating. This is instantiating what we just did. So you are seeing this is a variable and then config. So what is the feed? Max open coin. So now I'm now setting value like what we did. All right. So that is that. So you can see this application too. If you come here, what do you see? You see the same thing here, right? So you see, so the reason why we are having this sign is because we are, struct is a value type. So we have to pass it as a pointer, right? So since it's passed as a pointer, then there's a need to have this value because it's a pointer. So that's what you can see the config. Can you see that this is struct embedded? This struct is embedded here. So you can see that I say config is equal to db config. This is it here. This is the db config here, right? So setting it there, and then the next thing is store and store. So that is that. So what I want to now show us is to show us interface. So let's go to repo. So we can see this repo. What's the observation? First observation is to see that this is struct, right? So this is struct. Let's forget about this. We are seeing that what does this? This is what? This is a factory function. So this function, when I call this function, what this function does is to instantiate this struct for me. So this is just to instantiate. It's instantiating it. So if we come back to our main, go back to our main, you will see where I said new stock, new. Where's our? Let's go back there. Uh, new tag store. I want to see where I'm using that new tag store. New tag store. Okay, I'm not using it here. All right, so let's go back. Just want to show you guys. Okay, so I'm instantiating. I will show you where I'm calling this. So I'm instantiating, and then the next thing that we now have, you can see that we are having what we are having here are what? They are methods. Okay, they are methods. Every other things you are seeing here, they are methods. Every other thing you are seeing here, this is a method, this is a method, this is a method, right? Method, you can see that this struct is being passed down to each of those methods because these functions are acting on these structs. Okay, so that's what I'm just trying to say. You can see that this is we are passing it down because this struct here is needed in the functions. And how do we do that is to make it a method. Okay, but this is a function. This is a method of this struct. That is what it is. Right, so let's go to the interface. So here is where I'm creating interface. So let's check this out. Right, so I'm creating interface here. So you can see that the interface has a series of methods. Right, so this interface has what? Series of methods. Right, so the series of methods they have is being implemented by this struct. So if you check this struct now, you see that we have create tags, get all tags, getting single tags, toggle tags, delete tags. They are all here. Right, so the essence of interface is to create an abstraction. So an abstraction that you don't want the implementation details to be exposed. You're just creating an abstraction. An abstraction in the sense that maybe you have a plug in your house, right, and you just plug to power. You don't know what is going on. You don't know the details that is in between. All you just need is just that a plug to plug into your light. Do you get that? So I've created an abstraction here that if I want to change, for instance, I'm using, if I want to change this, right? If I want to change this implementation, I don't have to make any correction anywhere in my code, right? Because I've created an abstraction, so I can replace whatever is here. All right, so all I just need to do is I can delete everything and then create another struct. So what I just need to make sure is that the structs I'm creating, right, implement this method I have defined here. That's just what it means. You just have to implement the methods that I have defined here. So you can see that. So here I have a function that returns this interface. So this is a new function which I told us that it is what? Factory function. We see that this return the interface and then you're having store, right? So if you check here now, this store is coming from what? It's coming from here. So even though it returns the interface, but because the structs implement the interface, so I can return this. All right, so I can return this and then we have db equals to this. So that's that. So if you see in my code now, right, so one quick thing before I leave is you can see tags storage. So if you come back to here, let's come to our API. So what is you see? Repository dot tags see interface. All right, so that is just it here, right? So repository dot the interface is what I have. Now with this interface, right, that I've done, so if you go back to my handler, let's go back to my handler. So you see APIs here, you can see how I created this guy here, right? So I'm passing in, this is a method, then application, you can see that I'm passing this. What am I passing? I'm passing this guy here. So it's just a way of dependency injection, right? Just creating layers in your code. So I have repository layer, I have the transport layer, right? So If you come back to my handler, you see my handler. Let's take this now. So I'll stop here. So you see my handler, right? So this is my handler, and I want to show something. So you see, I'm setting something and say error a equals to app.store.toggle, right? So store, where is the store coming from? You can see the store dot what? Dot task completion, right? Task completion. This is coming from what? The interface. See, you can see it here. Don't forget that this task completion is also what? Implemented by what? By this guy here. And so what I have here is an implementation that create tasks that interact with the database. This is what query. This is what interact with database. You get that? So this interface just gives me an abstraction. So everything I'm using this handler is just calling those methods. It doesn't know the implementation details, right? So what interface helps to do is to just, you know, create an abstraction, and then, you know, you don't have to, you don't need the implementation details, right? So that means I can change this with another thing. I can replace this, maybe whatever I'm using there, it could be, I can make it a MongoDB and all of that. But what matters is that the method I have created here must not change. So that is it, guys. And so we are going to be stopping here, and I'm looking forward to maybe look for a more way to really explain interfaces or structs, maybe use more examples and all of that. But I want to believe that with this practical example, I know that once you begin to work with interface and struct, you get to understand it much more better and all of that. So, and in subsequent videos, I'm going to be working on projects where I'm going to be using interfaces and then using struct and all of that. So with diagrams to help us understand better. So thank you, and please don't forget to like, to share, to subscribe, so that, and then turn on the notification bell so that as soon as I upload another video, you get notified. Thank you and bye.